Okay, so welcome back to our subject, Digital Technique Fundamentals. So our lesson for today is how to make a schematic diagram of the different types of logic gates. Right? So we have discussed the different types of logic gates, such as our inverter, the AND gate, the OR gate, NOR, NAND, XOR, and XNOR gate. So those are the different types of logic gates. Now, before we go into the detail on how to make the schematic diagram, for example, on inverter, let me discuss first to you our template for our laboratory activities. For the first one, we have submitted by, so you write your name here, submitted to the name of your professor, date submitted, then you have subject, BCA122, block, then you write your block number here, then the objective, since we will be performing inverter, so our objective is to know the schematic diagram of an inverter. Okay, now this is our template, alright, for making a schematic diagram. This is actually a requirement on the actual laboratory activities on the inverter. That is if we have the face-to-face activity. Okay, so what are the requirements? You have here the symbol. So we have here the symbol of an inverter. You have an input A. The output is A complement. Then we have here the truth table. Input here is A. Input 0, 1. And A bar is 1, 0. Right? Then we have here the circuit diagram. We have the symbol connected to a light emitting diode. And then a resistor, 470 ohm resistor. Then connected to the ground. Then we have here the materials. We will be needing this if we have, again, a face-to-face laboratory activities. No? So we have one IC 7404, one breadboard, one light emitting diode, one 470 ohm resistor, 1/4 watt, and then we have 12 connectors. Okay, so telephone wire connectors, for example. Then you have one DC power supply. So as much as possible, variable, no? From 5 volts to, say, 24 volts DC. Or if you have, we can use also a battery, 9 volts battery, no? For our power supply. Okay, so this is our area here for making the schematic diagram. Okay, now this is our IC 7404. So if you will use the Google, okay, you can ask for the schematic diagram of IC 7404, and this will come out in your screen. Okay, so in this particular integrated circuit, we have here 6 inverters in one integrated circuit. Now, we have here pin number 1, 2, 3, 4, 5, 6, 7, then ground, 8, 9, 10, 11, 12, 13, then you have the positive VCC. Alright? Now, how do we know that this area here is 1, not this one here? Now, if you look at the IC, there is what we call a half moon there. When you have a half moon, what is under the half moon is your pin number 1. Okay, that is in every integrated circuit. Okay, and after a half moon, under it is your pin number 1. So this is a 14-pin integrated circuit for 7404 or your inverter. Alright, so how do we connect this schematic diagram? So we base our schematic diagram on our circuit diagram. If you notice that we have only one input for our inverter and one output for our inverter. So in this case, we will be using only one of these 6 inverters here inside your 7404. So for example, if we will use this particular inverter here, the input will be connected to your pin number 1 and your output will be connected to pin number 2. So for pin number 1, you put an arrow here. That means that the arrow here represents a wire, a hanging wire. Now, this is your input A. Alright? So this is where we will place our value, no? Either 1 or 0, no? As based on our truth table. Now, the output here is represented by 2. That means that this one here, in the circuit diagram, this is 1, and the output here is 2, which is your A bar. So you connect a wire here. Okay? Now, since 2 here is connected to the light emitting diode, so you place your connection outside your integrated circuit, and then you connect your light emitting diode. Okay? This is the positive side of your light emitting diode, and this is the negative side of your light emitting diode. Then, from here, you connect in your circuit diagram, there is a resistor here. So you connect a resistor. Okay? One of the terminal of your resistor is connected to the negative part of your light emitting diode. So again, this is your lead. And this is your 470 ohms resistor. Now, the other terminal of your resistor from here, if you notice, is connected to the ground. Okay? So, since pin number 7 here is ground, so you put a wire here going to the other terminal of your 470 ohms. Now, take note that your lead here and your resistor, 470 ohms, should be outside your 7404 IC. Not here. Not in this particular side, but outside of your IC 7404. Okay? So you have now a ground connected to your 470 ohms. To complete the circuit, let's say for example, you have here a power supply. Let's say you have a power supply. Okay? So you have a positive and negative connector, right? Then this is, for example, this is 5 or 9 volts DC. Okay? So the positive side of your power supply, this is your power supply, should be connected here in your VCC. And the ground here, this one here, which is pin number 7, should be connected here in your negative side of your power supply. Okay? Now, how do we perform our activity? We base our activity on the truth table. We are actually proving here if the truth table is true or not true. So for example, if A is equal to 0, that means that your A here should be connected to the ground. Okay? Again, if input A here is 0, that means that A here should be connected to the ground. Once your power supply is on, since A is connected to the ground, this inverter here will provide a 1 output, which is high. So the output here, which is in pin number 2, will transmit a supply going towards your light emitting diode. Alright? Now your light emitting diode, since this is anode here, this is cathode, positive, negative, forward bias, this will lit, musiga ang imong light emitting diode. And then going to your resistor here is just to protect your light emitting diode nga dili siya kung for example taas kayo kuryente, your resistor here will protect your light emitting diode so that your light emitting diode will not be busted, no? So dili siya madaot, dili siya masunog. Then you will be in this particular case, the circuit will now be completed. So if your LED will lit, that means that your output here is 1. Okay? Now, for the second condition, if A is 1, that means that this A here should be connected to your VCC or pin number 14. Kaya wire man ni siya, i-connect na nimo siya sa pin number 14, then that means that your A input is 1. Okay? Now, since this is an inverter, if input A is 1, that means that your inverter will produce a 0 value, thus making your light emitting diode to open. Okay? So, dili siya musiga kung mo-open siya. So, that means that the output here of your light emitting diode, dili man siya musiga, that means that the output is 0, which is this one here. Okay? So, that completes the schematic diagram of our inverter. So what we are doing here is we are circuit tracing. Okay, we trace how this one here is connected. This one here is how it is connected here, and then we are also connecting our circuit. No, in the actual laboratory activities, you will be doing the real connection, okay, using the connectors there and your power supply together with your light emitting diode and your 470 ohm resistor. So, for example, if you have in your experiment the AND gate, okay, so you search for the schematic diagram of your AND gate, no? Of course, you have to provide also the requirement here. What is the symbol of a 2-input AND gate? The truth table of a 2-input AND gate. The circuit diagram of a 2-input AND gate. The materials, all you have to do is to replace this with AND gate is actually 7408. Okay, so you just replace it with 7408. And that's it. The other requirements are the same. Okay? So if you notice that in your AND gate, this will be your circuit diagram, no? You have 2 input. Say input A and B. And then you have an output Y. Okay? So in your schematic diagram, there will be an AND gate here. Okay? In your schematic diagram 7408. Now, there will be 2 inputs represented by input A and input B. So, there will be 2 inputs here which will be hanging, no? So, inana ang ato ang pag-connect. Then, later on, we will connect this to your light emitting diode and then, again, a resistor. Just like this one here. This one here is 1 input. This one here is a 2-input AND gate. So that will be your next laboratory activity, no? The schematic diagram of an AND gate, and so on, no? Up to exclusive NOR gate.